Hello and welcome back. Today we are going to be starting our behaviorism unit, also known as the learning unit. In this unit, we are going to be taking a look at the ways that we can shape behavior using external forces. The three major categories in this unit are classical conditioning, operant conditioning, and observational learning. And today we're going to focus on classical conditioning, what it is, how it was discovered, and some of the major considerations that we need to think about when using classical conditioning in our own lives. So let's go ahead and take a look. Today, what we're really going to be focusing on is how to identify the parts of a classical conditioning experiment: the neutral stimulus, the conditioned stimulus, the conditioned response, the unconditioned stimulus, and the unconditioned response. And classical conditioning was really founded by a man named Ivan Pavlov. And Ivan Pavlov was not actually a psychologist, but a physician who was interested in studying digestion and the role that saliva plays in digestion in dogs. So what he did was set up an experiment where he would feed the dogs and measure the amount of saliva that was produced. But what happened was he noticed a really interesting phenomenon as he was preparing to feed his dogs. Prior to the dogs being given the food, they already started salivating, either at the sight of the food or eventually just at the footsteps of the person coming to bring them the food. And so he ended up creating a series of experiments where he used things like sounds or lights to see if that could indicate to the dogs when the food was coming and if the sound itself was enough to cause them to start salivating. And turns out it was. And so this is what classical conditioning is. It shows us how we could have an involuntary response to what was once a neutral stimulus when paired often with an unconditioned stimulus that elicits an unconditioned response. So to set up the vocab within Pavlov's original experiment, a neutral stimulus is something that on its own doesn't typically cause a reaction in an organism. In this case, the bell, right? A bell doesn't usually do anything physically in our bodies, except for maybe indicate to us that something's about to happen. But when it was paired with the unconditioned stimulus, the food, when the bell is paired with the food enough times, the unconditioned response of salivating or drooling eventually turns into a conditioned response to the bell. So that neutral stimulus paired enough times with the unconditioned stimulus becomes the conditioned stimulus. And the conditioned stimulus can now cause a conditioned response. The sound of a bell can now make a dog drool even without the presence of the food. That is what classical conditioning is, and that is what classical conditioning does, is it creates the conditions for an involuntary response to what was once a neutral stimulus. Some basic background vocab to be familiar with when it comes to classical conditioning. The first one is acquisition, and that just means that classical conditioning has taken place. Once the bell itself was enough to make the dogs drool, we can say that acquisition took place in that experiment. If you wanted to do an experiment on yourself where you ring a bell and say, turn the lights off in a dark room, what happens over time is that ringing of the bell will be enough to make your eyes dilate, all on their own, because the bell signals that the lights are about to go off. And even when you don't turn the lights off, the bell sound can cause that physical reaction in your body and make your eyes dilate. So if you ring a bell and your eyes start to dilate, we know that classical conditioning has been acquired. We know that acquisition has taken place. Generalization is when other similar stimuli start to elicit the same response in classical conditioning. So if the bell is what made the dogs drool in Pavlov's experiment, maybe a different bell sound or a different tone, maybe a phone ringing, causing them to drool. would be an example of generalization. If you were to do the experiment where you ring a bell and turn the lights off multiple times, maybe the sound of a different bell would make your own eyes dilate. If that happens, it means that generalization has taken place. If those other sounds don't elicit a response, if they don't make the dog drool, or if it doesn't make your eyes dilate, that means that you are experiencing discrimination. And in this context, discrimination means that your brain can tell the difference between these sounds and only responds to what was once the neutral stimulus that is now the unconditioned stimulus. Over time, when we stop pairing the neutral stimulus with the unconditioned stimulus, when the bell sounds but the dog doesn't get food, eventually the response is going to go away. And that is known as extinction. Meaning after a while, the body is going to figure out that the bell no longer means food is coming. The dogs are going to stop salivating at the sound of the bell. When that happens, extinction is taking place in classical conditioning. Now, if extinction takes place, the good news is we can always recondition. After conditioning, we can start the whole process over again, ring a bell and give some food, ring a bell and turn the lights off, and it's not going to take as long for the body to figure out that conditioning is taking place again, and acquisition is going to happen a lot faster the second time around than it did in the original experiment. If it took your eyes 10 times of pairing the bell and turning the lights off to make your eyes dilate, the second time you do it might only take 5 or 6 times, and that is reconditioning. And the reason why reconditioning is faster and easier is due to savings. And savings just says that we've retained the learned associations. It's the reason why we can be reconditioned, because the brain and the body hold on to the memory of the original conditioning. And that's why it happens faster. If after extinction has taken place, you don't recondition and time goes on and you no longer have the conditioned response to the stimuli, what you might see one day randomly out of the blue is that all of a sudden, one time ringing the bell will all of a sudden cause the dog to start drooling again, or could all of a sudden cause your eyes to start dilating again. If that happens, that is known as spontaneous recovery. It's a phenomenon that happens when the conditioned stimulus all of a sudden causes a conditioned response, even without the presence of the unconditioned stimulus. That is known as spontaneous recovery. And then finally, a very interesting phenomenon is known as second order conditioning. And this is where something new is going to cause a conditioned response due to the pairing of the conditioned stimulus with something else. So say, for example, you hear that bell sound at a sports match, and so your eyes start to dilate over at the football field. And one day you walk over to the football field, and the football field is what causes your eyes to dilate even without the presence of the sound. That would be called second order conditioning. Now the location has become the conditioned stimulus that elicits the conditioned response. And blocking is what happens when we can't recondition to a new neutral stimulus. If we try doing the same experiment with a whistle instead of a bell, but that discrimination is taking place, we might not be able to be as successful conditioning a dog to drool at the sound of a whistle, because they still have the memory, the savings of the conditioning taking place with the bell. And so if it's not successful, we call that blocking. Now, what makes classical conditioning successful is something that is up for debate. The contiguity theory of classical conditioning, according to Pavlov, said it doesn't really matter what the neutral stimulus is, as long as you pair it with the unconditioned stimulus enough times. Meaning the more you pair it over and over and over again, the stronger the conditioning will be. So the more you pair it, the stronger the conditioning is the basis of the contiguity theory of classical conditioning. Other psychologists disagree. Robert Rescorla, for example, said that it was the contingency of classical conditioning, how predictable the neutral stimulus was at indicating the unconditioned stimulus and unconditioned response were going to take place. For example, if we were going to use a bell to indicate the end of class, that is very different than, say, using the sound of a cow. If a moo went off over the intercom, it might not be as successful as indicating that class has come to an end, because bells in our society often indicate the start and end of a variety of things, like class or sporting events or other things like that. And so it's the sound itself of the neutral stimulus that causes the response, not necessarily the number of times it was paired. Because if we were to use a different sound, like of farm animals, for example, it might not be as successful in classical conditioning. And to end today, we're going to take a look at the patterns of classical conditioning. One of my least favorite things in classical conditioning are the different timing mechanisms of classical conditioning. What we call traditional or forward conditioning is what we have been talking about, where the neutral stimulus comes right before the unconditioned stimulus, usually about a half second. But we could also experience what's known as backwards conditioning, where the neutral stimulus follows the unconditioned stimulus. It's not as successful in a lot of context. So for example, if we were to turn a light off and then ring a bell, chances are our eyes are not going to dilate at the sound of a bell because the lights are already off. But in some cases, something like perhaps someone who gets into a car accident and goes to the hospital might then have a fear of not cars, but going to a hospital. That would be backwards conditioning, because the hospital came after the event of getting in the car accident that caused the fear. And so that would be an example of backwards conditioning. Delayed conditioning does not mean that there is a delay between the neutral stimulus and the unconditioned stimulus, because that would make too much sense. Instead, delayed means that the unconditioned stimulus and the conditioned stimulus overlap, meaning as one is going on, then we see the introduction of the unconditioned stimulus. So as I'm ringing the bell, then I give the dog the food and the bell is still ringing. That is delayed conditioning. Simultaneous conditioning is when the conditioned stimulus or the neutral stimulus and the unconditioned stimulus are presented at the same time. So right as the bell starts ringing, I give a dog the food, or right as the bell starts ringing, I turn the lights off. That would be simultaneous conditioning. And trace conditioning is when there's a delay. So trace conditioning means that the neutral stimulus is introduced, but then after a while, an extended period of time, then the unconditioned stimulus is presented that causes a conditioned response. That is where we see trace conditioning. This is most common with things like food poisoning, because it doesn't usually happen instantaneously. You could eat something, several hours later get sick, and then have an aversion to that food moving forward. And that would be a result of trace conditioning. Food aversion is usually the most successful type of trace conditioning, because typically other types of trace conditioning are not going to be successful. And then temporal conditioning is timed conditioning. So being presented things at intervals, and we start to notice those patterns emerge. Think about on a regular school day, the times in which you eat food. If you eat every single day at 11:30 during the school year, maybe by summer you're sleeping in until 9 or 10 o'clock and you eat breakfast, and all of a sudden you notice you're hungry again at 11:30, even though you just ate, could be because of temporal conditioning. Because you've been conditioned to eat at the same time every day, you start to feel hungry at that time, even if you actually just ate some food. And then again, the normal type of conditioning is known as forward or normal conditioning, where the neutral or conditioned stimulus is about a half second before the unconditioned stimulus. Lastly, there's just a couple of things we'll take a look at here in terms of some unique phenomenon in classical conditioning. Little Albert is another great example of classical conditioning. And this was very interesting when John Watson did his experiment on little Albert, because it proved that conditioning Emotions to neutral objects is possible. By scaring little Albert every time he reached for a white rat, developed into a fear of all small fuzzy creatures, we see both generalization and we see that classical conditioning of fear. And taste aversion. As we mentioned before, that taste aversion is one of the few times where trace conditioning is successful, that hours can pass and you will still feel the effects of trace conditioning and you can have a built-in aversion to that food. Why does that happen? It's a survival mechanism. Our body is designed to identify foods that could be potentially harmful to us so that we don't eat them again, so that we don't potentially die from eating them. So even sometimes we'll eat something and instead of get food poisoning, maybe we just get the flu. Maybe we are just under the weather, but we still no longer want to eat that food. It's because of this biopreparedness that our body has to reject food that we think could be potentially harmful to us. And there's been some really interesting research on this, particularly with rats in radiation chambers who became sick, not from the radiation, but from the taste of water coming out of the plastic water bottles. Because the plastic water bottles precipitated their illness, that's where the taste aversion came from. So you can think about this for yourself if you have any food aversion to things that have made you sick in the past. We're going to go ahead and stop there for today. That's a lot of information on classical conditioning. But next time we meet, we're going to learn about operant conditioning and how rewards and punishments shape our behavior. So thank you so much for watching, and remember, be kind to your mind.